Hi boys and girls. We've been talking about long multiplication using 3 digits times 1 digit and 3 digits times 2 digits. Today we're going to extend our thinking just a little bit farther and use some bigger numbers. Let's get started. So here we have 4,219 times 53. The process begins the exact same. We're going to start multiplying out of the ones place and multiply it up to every single digit this way until we get an entire partial product. Then we're going to remember that next we multiply out of the tens place, so our answer should start in the tens place, meaning we should have a 0 placeholder. We're going to then multiply to every number across the top until we have a total second partial product. We will then add the digits and get a final product. So let's make this a clean slate and try it together. So first we start multiplying the 3 by that 9. 3 times 9 is 27. And when I carry the 2, I'm going to circle it so that I don't forget to use it later. Next I move over to the tens place where the 1 is. 3 times 1 is 3, plus the 2 is 5. I move over to the 2 in the hundreds place. 3 times 2 is 6. And then finally to the 4. 3 times 4 is 12. There's no place for me to carry the 1, so it just drops right down with the 2. Now that I've finished multiplying the 3 with all the numbers across the top, I'm going to cross those numbers out, the 3 and any of the regrouped circled numbers, so that I don't accidentally use them for the next number that I'm multiplying, which is the 5. I move over here to the 5, and since I'm multiplying out of the tens place, my answer needs to start down here in the tens place, which means that I need to give myself an invisible 0 here and really make it a true 0 so that it's a placeholder. So now I repeat the process, multiplying the 5 to the ones place, the 9, and then all the way across till all of my numbers have been multiplied. So 5 times 9 is 45. Carry that 4 and circle it so we don't forget to use it. 5 times 1 is 5, plus the 4 is 9. Then across to the 2, 5 times 2 is 10. Carry that 1 and circle it so we don't forget it. 5 times 4 is 20, plus 1 is 21. And again, the 2 drops down because there's no place to regroup. I need to make sure I add my plus sign so I remember now I'm adding instead of multiplying. And all that's left to do is add these two numbers, which are called partial products. Partial means part of, so they are part of the entire product. So if I add, again regrouping and not forgetting those numbers that I'm carrying up there, and the last thing I need to do is count 3 digits over so I know exactly where to place my comma. So my answer is 223,607. Here's a brand new problem for you to try on your own. Please pause the video, solve it, and then turn it back on to check your answer when you've completed the problem. Okay, so the correct answer is 462,722. Did you get the right answer? If we need to troubleshoot some things, the first thing that you should do is look at both of your partial products. Check to see that both of these answers are the same as mine. If they're not, then you might need to remultiply one of the rows. If they're the same, and just your final product is not correct, then you must have added somewhere incorrectly. Check these things if you didn't get the problem right and find your mistake. Now let's try multiplying 3 digits times 3 digits. the process here is still the same. We will just have 3 partial products because there are 3 numbers that we're multiplying by. So again, we start multiplying from the bottom using the 6 in the ones place, multiplying it across the top number. 6 times 5 is 30. 6 times 2 is 12, plus 3 is 15. And 6 times 4 is 24, plus the 1 is 25. Now, we're multiplying out of the tens place, so remember our answer must start in the tens place, which means that we must have a 0 placeholder. 3 times 5 is 15. 3 times 2 is 6, plus 1 is 7. And 3 times 4 is 12. Now we have one more place to multiply out of, which is the hundreds place. So you guessed it, our answer must start in the hundreds place, which means we have not 1 but 2 zeros that are placeholders. So 1 times 5 is 5, 1 times 2 is 2, and 1 times 4 is 4. The last step is to add those all up. So our final answer is 57,800. Let's try one on your own. Write this new 3-digit times 3-digit problem down and solve it on your own. Pause the video while you solve it, and when you're ready, turn the video back on to check your work. So the final answer here is 58,956. Remember, you have some problem-solving tools. You can check your partial products with the ones that I got. If those are all correct and match mine, then maybe you added wrong. The last thing I want to show you today is a different method in order to solve long multiplication problems. Some students have a hard time remembering 0 placeholders or keeping their columns straight when they're adding. This can lead to very easy miscalculations and then cause you to get the problem wrong. So we're going to start with this problem, 456 times 12, and we're going to try a new method, a method called the lattice method. Let's take a look at what that looks like. So you can see I took the number 456 and wrote it across, but I left myself some spaces between each number. I was multiplying by 12, so I wrote that vertically here on the side, and again left some space between the numbers. Next, I'm going to draw a big box. I'm going to make sure that each number at the top has a column. So there's a number column for the 4, a column for the 5, and a column for the 6. And then I'm going to make sure that the numbers over here on the side, the 1 and 2, each have their own row. The last thing that I want to do here is to cut all of my boxes in half diagonally. So now I have this crazy looking box with a bunch of lines through it, but how is this supposed to help me multiply? Let me show you how it works. I'm going to start here with the 6 and the 1. I'm going to multiply them. 6 times 1 is 6. So I'm going to put a 0 and a 6 in this box. 6 times 1 is 6. I'm going to move over to the 5. 5 times the 1 is 5. So again, I need to make sure that I use 2 digits, so I'm going to use a 0 and then a 5. And then moving over to the 4, 4 times 1 is 4. Now I'm ready to move down and multiply by the 2. 6 times 2 is 12, so the 1 goes in the top box and the 2 goes in the bottom box. 5 times 2 is 10, so the 1 goes in the top and the 0 goes in the bottom. And then 4 times 2 is 8. So I'm back to using a 0 with the 8. Now that I've done all of my multiplication, and you can see that it split these up into very basic math facts. I haven't had to worry about carrying any numbers across, keeping any columns, or using any zero placeholders. So, just like in traditional long multiplication, after I multiply everything out, my last step is to add them. This part can look a little confusing because students can't always see, but you're actually going to add the numbers that line up diagonally. Sometimes I have students that like to take highlighters or even colored pencils or crayons and lightly color these diagonals so that they can see all the numbers that they need to include when they add. So if I add, starting in this first corner down here, there's nothing to add with the 2. So the answer is just 2, and I write it below that box. I'm moving over to the next long diagonal that I highlighted yellow, and I'm going to add 0 plus 1 plus 6 and get 7. Now I'm moving over to the longest diagonal line that I have in pink. 8 plus 1 plus 5 is 14. I do still have to worry about numbers that I'm carrying, so I carry the 1 from the 14 up to the next colored diagonal. And again, I circled the number so I didn't forget it. And I have many zeros here, so I really only need to add the 4 and 1 to get 5. And then my next number up here is 0, so I don't really have to do anything at all. My last step is to just take the numbers that I've written on the outside here and write them in standard form. So 5,472 is my final answer. Now I want you to try and solve this problem using the lattice method. I'll even help you set it up. Remember, each number needs its own column and row. And then we split the boxes diagonally. Next, we're going to multiply. I want you to pause the video here and try and do that part yourself, and then when you're ready, turn your video back on and check your work. So here's my work, and my final answer was 17,856. If you didn't get the same answer, the first thing to do is to check all of the different highlighted columns and see if you have the same numbers within your boxes. If not, then maybe your multiplication was off somewhere. It is really important to know your math facts here, as one wrong number can throw your entire answer off. If all of the numbers within your columns and boxes are the same as mine, then perhaps it was just a simple addition error. Here's the last problem that I have for you today. Please write this on your paper or on your desk with your Expo marker and solve it. You may use the traditional method or the box method, whichever one you find is easiest and works best for you and your needs. When you're finished, I'd like you to take a picture of it and post your work on Seesaw so I can see how you're doing with this concept.